Welcome everyone to this week's presentation from DBA Fundamentals. This week is Uncovering Duplicate, Redundant, and Missing Indexes with Endian. Today is April 11th, 2023. And the top right-hand corner of the screen, you'll see all of the leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If for any reason you need to get a hold of us, the easiest way is probably by Twitter, at least for right now. Just reach out to us via Twitter and you'll get us pretty quickly. Below that is the various ways you can get to DBA Fundamentals on social media. First one, obviously, is meetup.com, where we have all of our things set up to go through. If you need to get to see what's coming up, there's the best place and one of the easiest to actually connect and find where all of it's going to be. Then below that is one of my favorite websites, our website, dbafund.org, where you can see all of our upcoming presentations as well as all of our past presentations as well. We have, at this point, over 10 years of presentations we've given. Below that is my favorite video site on the web, dbafundtube.com, where you can see all of the past presentations. When you go there, if you haven't already, please make sure to actually like and subscribe. Then you can see all the presentations when they actually go live, which usually is within a day or two. We try for that anyway. Sometimes life happens. Below that, you'll see various ways you can get in touch with us as a group. DBA Fund is our Twitter handle. Below that is also our Slack and LinkedIn groups, where we have various conversations. As I said earlier, our sessions are recorded and usually available within 1 to 2 days. Be sure to check out us on our YouTube channel, dbafundtube.com. As a reminder, please be sure to turn off your camera and mute yourself. I'll be doing the same here in just a minute so that we can all focus on Andy and see all this goodness that he's going to present to us. And also be sure to type any questions you have into our chat so we can keep it flowing. And with that, I turn it over to Andy in our small little verb. I'm sure he has a much better one and we can all listen to all the goodness.
All right, thank you for that introduction. Let me start my screen share. Can someone please confirm that the screen share is coming through?
I see it.
Outstanding. And again, if folks who are on the call can please ensure that they are muted, please, that would be great. All right, welcome to a new edition of Uncovering Duplicate, Missing, and Redundant Indexes. My name is Andy Yoon, blah, 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 blah. So I've been working with SQL Server for quite a while. I happen to work for a company called Pure Storage. I am still somewhat active on Twitter these days, but otherwise you can find me under the alias SQL Beck. That is very important to know. Also to find my blog and my GitHub. My GitHub has copies of all the scripts and stuff like that that you'll be seeing today, the different T-SQL tools and stuff like that, and my demo databases. Some of you also may know my amazing spouse, Deborah Melkin, who is also a SQL Server developer and speaker in the community. And maybe if some of you saw the past Summit keynote, you'll also recognize our little dog, Sebastian. So anyways, enough about that. So let's get into the session itself. Have you ever asked yourself any of these questions about the indexes that are in your environment today? You know, there's a lot of us who, depending on the role that you're in, whether it be developer or DBA or oftentimes a mix thereof, sometimes you're in charge of the indexes that you happen to have, like you're the one responsible for creating them. Other times you may wind up inheriting them, maybe like you're an operational DBA, but it's the developers who choose to create the indexes for their different applications. So you're the one who just kind of has to, keep the lights on, if you will, right? But in either case, I would strongly argue that no matter what your role is, it is very important for you to be mindful and keep in mind all of these different possible questions about your index usage. They have consequences. your workload, but are there times where they could also be hindering your workload? That's something that not a lot of folks oftentimes consider, right? Because we usually create indexes with the best intentions, but oftentimes, like a lot of other things, they remain in place, but the application changes and evolves over time, and sometimes our indexes don't evolve accordingly. So that is kind of the foundation for this particular presentation. And to kind of take us on this journey about dealing with those duplicate and missing and redundant indexes, the agenda for today is, first we're going to cover a little bit of index internals. I like to set a bit of a foundation to make sure everyone knows a certain set of knowledge, which we will then be returning back to. So we're going to do a little bit of a deep dive into index internals. And then immediately thereafter, we're actually going to be spending the second half of this entire presentation all inside of T-SQL and demo in Management Studio. So we'll be talking about T-SQL tools and the index analysis demo in of itself, okay? So I will be monitoring the chat. So if you happen to have any questions, please don't hesitate to ask. And yes, I do talk a bit fast. Sorry, it's just the way it is. However, of course, this is being recorded, so you can go back and watch it at a future point in time. So let's get started with B trees and index operations. So for the purpose of the next 10-15 minutes, we're going to be working with this simple customer table, and you can see it's pretty straightforward. I've right-sized my data types and whatnot as well. Focus more on the bottom. The non-clustered index is what we're going to be talking about today. This non-clustered index has two key columns, last name and first name, and then it has two included columns, first visit and the email address, okay? So hopefully you understand the difference between key columns and included columns, but long story short, included columns are just kind of come along for the ride. They're extra pieces of information for reference purposes, but they don't help you when it comes to navigating your index, and you'll see that in a minute. So this is a simplified example of the B tree structure. B tree in this context does not stand for binary tree, which is what a lot of us oftentimes think about. In this context, it actually stands for a balanced tree, and that's how our non-clustered indexes are structured internally, okay? So this is kind of what it looks like, or an example thereof. Let's zero in a little bit. First, let's take a closer look at the root level, which is that top node of the non-clustered index. In this case, we're looking at a data page or an index data page, and in this simplified example, we happen to have three values, or three records, I should say. One for Adams James, another for Martinez Luis, and another for Simon Paul, which corresponds to the last name and the first name. Now, there's a third piece of data here. What is that? There's a number. If you remember our table was clustered on the customer ID, which was an auto-incrementing integer. That's what this number happens to be. It is your clustering key. A copy of the clustering key comes along for the ride and is materialized in all nodes of your non-clustered index. So whenever you have situations where someone wants to create a clustering key in a table that is multiple columns, then that has a consequence. It's a bit of a trade-off where, again, copies of those those clustering keys, plural, will also be copied here. But in this case, it's just a auto-incrementing integer, so it's just one value. Now let's add in the intermediate level. Of course, with a non-clustered index in a B tree structure, you could have many intermediate levels. But in this simplified example, we just happen to have one. And here are the first two data pages in that intermediate level. And notice that the first record of our root page is also the first record of the first intermediate data page. So Adam James here, right? And then the second value in the root node is the first value in the second intermediate level page. Say that 10 times fast, right? But hopefully you can get a sense of how SQL Server can use these as pointers. That's why this is created the way that it is. So we have these, again, that first value is that first value, that second value is that first value of the next data page, and so on and so forth. So if I had enough room on this screen, Simon Paul would be the pointer to the third data page, okay? Now let's add in the leaf level. I'm showing you the first intermediate data page, but now in the leaf level, it looks very similar in structure. And once again, we follow the same architectural pattern of that first value being a pointer and that second value being a pointer to the respective first records in the subsequent leaf level pages. Now, notice that there's a little bit of extra information here. First visit and email were our included columns. And notice those two pieces of data are also persisted here on the leaf level. So they're not going to be able to help us for navigation purposes, but if I'm executing a query that needed first visit or email, hey, I have it right here. If I needed other pieces of information, those are not available to me, and I have to do an additional operation. We'll get to that in a little bit. Okay, so speaking of index operations, let's start talking about the index operations and kind of what it all looks like. If you look in the upper right-hand corner, I have a simple query of a select first name, last name, first visit from this customer table. There is no where clause. So because of this, we're going to have to do an index scan because we're just saying, give me all of the first name, last name, and first visits from all of the records of customer. So the way SQL Server will navigate this B tree structure, it first must go to the root, and then it'll go to the first intermediate page, and then it'll go down to the first leaf level page, and then it'll scan across. There is no way for SQL Server to jump immediately to the leaf level. It must always start from the root. We will always navigate the B tree. Now, one way to measure the amount of work that SQL Server has to do is to measure the number of data pages, index data pages that SQL Server had to process. Remember that an index data page is an 8 kilobyte construct, first persisted on disk, of course, and then pulled into the buffer pool or RAM, and then processed inside of RAM, right? So how many data pages did we have to process? 10 data pages. And I forgot to mention, when we process one of these data pages, that is known as a logical read, okay? So in this case, we executed 10 logical reads, or we had to consume 10 data pages, including the root and that intermediate level to navigate on down, okay? So this index scan costs us 10 data pages, or 10 logical reads, is kind of how we say it. Now, let's modify that select statement and add in a where clause. So now we have where last name is equal to Dean. Now I can zero in on a specific record because remember the non-clustered index, its leading key column is last name. I must still first start at the root, but now I can say that, okay, the first two values are Adams and Martinez. I know that Dean falls in between Adams and Martinez, so I know to navigate to the first intermediate level page as opposed to the second or the third. Now in this case, Dean exists between the second and third values, Chavez and Howard. So I know to navigate to the second leaf level page in order to find where last name is equal to Dean. In this case, I didn't have to scan all of the other pages. I didn't have to consume all of the other pages. I was able to drive straight into what I needed. And as a result, from a logical read perspective, or the amount of work I had to do, I only had to do 3 logical reads. That's a big difference from the 10 logical reads that we had to do. And this is one reason why people love index seeks. We're going straight into the data that I exactly need, okay? Now, here's a slightly different variation of a where clause where last name is greater than Inez and last name is less than Sark. What do you think might happen here? Well, SQL Server is going to be able to do something kind of interesting. It's going to start with the first value Inez, and it's going to seek to where Inez exists on that data leaf page down there. But then it's going to do a partial scan across, what we call a range scan operation. So we don't have to scan the entirety of the index. SQL Server knows that I only need to go from last name Inez through last name Sark. I can omit the rest of it. And because the B tree structure is ordered by last name, I'm able to accomplish that. From a overhead or performance perspective, this only costs us 6 logical reads. Much better than 10 if I had to do a full index scan. Now I've changed things up. Instead of last name, we're now going to query by first name. Where is Arthur in this table? In this simple example, we see that Arthur is all the way down here. But because we must navigate using last name first, because that is our leading key column, How am I supposed to be able to find where first name is equal to Arthur, or I don't know the last name? The last name could be anything. There could be many Arthur entries in this particular non-clustered index. So what we must do, unfortunately, is still scan the entire non-clustered index, do a full index scan operation here, because we have no idea if there's going to be one Arthur or many Arthurs in this particular non-clustered index. So once again, logical reads 10 data pages. Now, one thing I've heard many times over the years is that seeks are always better than scans. In fact, I've even heard some people say that whenever they're performance tuning, if they ever see an index scan, they must eliminate them. They have some kind of hard, fast rule where seeks are always better than scans, and seeks must always be, or scans must always be eliminated, and you must only ever seek. That's not always a good idea. And here's a perfect example why. In this particular query, we have where last name in and a string, a handful of different last names here. What do you think is going to happen? What SQL Server will do is that it's going to seek on that first last name, Alan. But then it's going to do another seek, and then another, and another, and another for each of the subsequent last names. And what is the sum total of all of these individual seeks? 18 logical reads. Whereas if I had just done a full index scan, I'd have been better off with 10. This is one common use case as to when you're looking at your execution plans, you might scratch your head and ask yourself, why did I not get an index seek? Because I specified last names, I should be able to navigate on last names. But because you had a whole bunch of individual last names, you wound up doing a whole bunch of index seeking, and you would have been better off just doing one singular scan. Because again, a full scan is 10 data pages as opposed to 18 here in this simplified example. Okay, so this is a perfect example where seeking is not always better than scanning. Now, I've also modified this particular select statement to say select first name, last name, first visit, city, and state of our customer, where last name is equal to Huang. So we know the last name, so we can zero in on that. But my non-clustered index does not have a reference or an included column for the city or the state values. So what am I to do here? Well, first, we can navigate this non-clustered index and seek to our value where last name is equal to Huang. But remember, we've included a few data points like first visit and and that first visit date and wow, I totally forgot, or email address, right? But in either case, we don't have those here. So what do I have to do? I have to do what's called a key lookup operation, where I must go back to the base table, whether it be materialized as a heap or a non-clustered index, in order to get the other key pieces of information that we were requesting here, city and state. And of course, this incurs additional overhead, additional work behind the scenes that SQL Server must do. This is one of those hidden performance killers, because oftentimes what I see in workloads is that people will create perfectly crafted indexes for a given set of queries and that sort of thing. And those queries will go out to production, and the indexes will go out to production. 3 months later, hey, we need to make a modification to those particular queries because we need a few extra pieces of information. Not a problem. You put in the change request, we put out the new queries, but you fail to update the underlying indexes, and now you wind up with key lookup operations. During my time at SentryOne, when I was working, monitoring, different SQL Server workloads and whatnot, and helping people monitor workloads using different performance tools, key lookups was one of those hidden performance killers I saw in hundreds of different SQL Server environments. A lot of people didn't quite realize, that the price that you would pay for not keeping up with your indexing to match that of your query workload as your query workload evolves and changes over time. Okay. So let's do a quick, brief recap of some of the key points about, the index operations. Do remember that index key order matters, right? Remember how we were looking after first name. I can't, navigate through that. I must have a last name or whatever that first key column is in order to navigate that my B tree structure, right? And, I just spent a few moments really kind of trying to drive home the point of making sure that your included columns fully cover a given query. Depending on how your query workload is evolving, right? You may not need that first, city and state, for example, as part of your navigation, because maybe you never query by city and state, but you do need to return it all the time now. That would be a great candidate to put it into an include column. And hopefully have a better appreciation of why seeks are not necessarily better than scanned. It is a total myth that you should always seek and never scan, right? So keep that one in mind. One of the things to always look into is the properties by hitting F4 when you're looking at an execution plan on an index operator, and you can actually see the number of executions. And that'll be your telltale sign that you did a bunch of key lookup operations behind the scenes. So another thing to be mindful of is when it comes to how many indexes you happen to have for a given table and the storage footprint, right? And how much work you have to do behind the scenes to maintain all of it. So for a given table, you're only ever going to have a heap or a clustered index, right? A table will be materialized as one or the other, never both, right? So that's just the way the table is, okay? However, behind the scenes, you could have one, two, or many non-clustered indexes. So those are additional B tree structures. So obviously, just from visualizing it here, I'm going to have one on the left and potentially a whole bunch on the right. So it's more copies of my data. Now my non-clustered indexes, hopefully are just a subset of the columns and therefore the data points of my base table. But there could be many different varieties of non-clustered indexes that happen to be out there. And they must all be maintained whenever we modify our data. Let me show you what I mean. So if I do an update statement on my table here, I'm going to have to modify, a data page on, here or here, on my heap or my clustered index, right? And maybe I'm just, doing one single record as far as this update statement is concerned. Well, be mindful of all of the different possible places where that same data value might show up in our non-clustered indexes as well. Those must synchronously be updated during the DML operation, during the update operation, okay? So it's not like SQL Server can asynchronously update this later on down the line or something like that. All must be done. So instead of 1, 2, 3, 4, 5, it's 5 updates, not just one singular update of, one singular structure, okay? Also, if that value happens to be a key column, then we must also modify the root and any intermediate level pages as well. So that's something that could potentially hurt you as well. Similarly, for an index or a delete operation, well, now we must modify every single non-clustered index because, of course, there's going to be some kind of entry for every single record inside of all of my non-clustered indexes. So all of those constructs must be modified in the case of an insert or a delete as opposed to an update, okay? So again, there's impact, there's more impact behind the scenes depending on how much DML, insert, update, and delete type of workload you happen to have. So one common question is how many indexes are too many indexes? Unfortunately, there's not a magic number. Also, it depends on the type of database and table it happens to be and the type of workload. Is it a highly transactional table, a database? Is it a highly analytical table or database? What is the purpose behind it? How often is it getting modified, right? How much DML do you happen to have? Are you doing singleton inserts and updates all day long, or is it just like a once a day or once an hour ETL process that's just inserting a bunch of data and just doing one set of updates, again on a more of a periodic basis? If you happen to be in an analytical situation and you're doing, say, nightly ETLs, one thing that may be more advantageous to you is to disable all of your non-clustered indexes, do that massive update and that batch load or whatever, and then rebuild your non-clustered indexes rather than having to incur the overhead of rebuilding as you're doing your batch load in the middle of the night, right? So might as well just take that hit once after your entire ETL, because oftentimes when we're doing ETLs, people will still batch that up into smaller batches, right? If I'm inserting 1 million records into a table, a lot of us will do something like 50,000, 50,000, 50,000, or something like that for transaction log purposes and that sort of thing. So disable those non-clustered indexes so they don't get updated. Do those different batch inserts and stuff, and then just do the rebuild once, right? As opposed to having to incur the updates against those non-clustered indexes multiple times when I don't care about it in the process of the ETL. Now, this is a number of years old, but I still find this very insightful just to see what did other people do as far as their tables are concerned. So Paul Randall of SQL Skills had people, just run a simple query, just again, get a better sense of how many non-clustered indexes did they have. So check this out. I find it kind of fascinating. So with that, I'm going to pause for a moment before we dive into the T-SQL tools and analysis, both to take a drink of water and to see if we happen to have any questions in the chat. I don't see anything in the chat as of right now. I'm just going to write a quick test hello just to make sure I can actually see everything in the chat. Because I was having some issues with Teams and some of my Teams information not coming through, and actually I can't even see my own message, so I may not be able to see the chat. That's, yeah, my test hello failed to send. Okay then, well, yay Teams. So in this case, what I'll do is I'll ask Kevin if there happens to be any questions in the chat, just to check for me. Kevin, you there? Kevin? Am I still there?
Yeah, you're still here, Andy.
Okay. All right. Thank you for that, Andy. Andy, can you see the chat? Are there any questions there? I'm going to make you guest moderator right now.
All right. Yes, you do have one question from Lars. Lars wants to know, should we disable non-clustered indexes during rebuilds?
Should we do this? That's interesting to me, because the thing is, when you disable a non-clustered index, when you rebuild it, that's essentially, when you're turning it back on, it essentially is a rebuild operation. So are you suggesting, like, if I have 10 non-clustered indexes, disable them all and then just rebuild one at a time? The answer would be no, because you're only rebuilding one non-clustered index at a time. So the answer to that is no. It's when you're updating the base table, because then all the non-clustered indexes must all be updated simultaneously and synchronously, right? So that's kind of what I was getting at. So hopefully that answers your question. Anything else?
There's a question about, will the presentation be shared?
Yes.
I believe these are all shared.
Yep.
We have another question. Removing or disabling indexes increases insert, but what if we face index rebuild takes a long time to complete?
If your index rebuilds take a long time to complete, I mean, that's kind of a different challenge when it comes to, as far as index maintenance. There are different strategies and mitigations around that. That's not I don't want to spend 5-10 minutes going down that particular tangent or rabbit hole, but do email me later on, sqlbeck@gmail.com. I can help point you towards some of those different maintenance type blogs and whatnot. The one that really comes to mind that I've always really enjoyed, Kendra Little. Look up Kendra Little and then index maintenance. She has some fantastic blogs and writing about different strategies and whatnot when it comes to index maintenance. But unfortunately, that is a separate topic in of itself. So I'm not going to go further into that. Great question, though. Anyone else?
No, we don't have anything else right now.
All right, outstanding. Let's pivot over to demo time. Okay. Everyone, can everyone see Management Studio okay?
Yes, we can.
Outstanding, thank you. So for the purpose of this demo, we're going to be using a demo database of my own creation called the Auto Dealership Demo. It is available up on my GitHub. And we're going to be using a flat singular table called Inventory Flat. Right. So this particular table just has a whole bunch of data points about vehicles and that sort of thing, things that I've kind of serialized and materialized in here. OK, Now, one cool thing, this is a little bit of an aside, but I love to share these quick tips, is that, SQL Server happens to have a built-in stored procedure called SP help. I really like using SP help a lot because it gives me a whole bunch of information about the table at my fingertips, right? So, like the different column names, the underlying data types, if there are, whether it's clustered or all the way at the bottom, whether there's any, oops, not this one here, this one here, whether there happens to be any non-clustered indexes as well. And we do see that there's a whole bunch of non-clustered indexes. This is for the constraints. So that's pretty cool. If I only want to see the index information, I can then instead execute SP help index here. And we see that this flat inventory flat table happens to have 14 non-clustered indexes, and then a clustered index on inventory flat ID. Now, looking at the output of this, is there something missing here? My included columns. Unfortunately, SP help index does not show you that information. It's been a shortcoming of this stored procedure, and one reason why I actually never use it. Instead, what I strongly advocate use of is Kimberly Tripp Randall's version of SP help index, which she has written here. So when I execute this, and this is one of the stored procedures that goes on all of my SQL servers, in addition to things like SP who is active and whatnot. But if I scroll over to the right here, I have not only index keys, but I have some other pieces of information here, like included columns, or if there's any filtered indexes, for example, and there's other data points in here. This is now useful to me, so now I can see what is truly included in a given non-clustered index, which is oftentimes very important, especially when we're trying to track down our redundant indexes. So typing all of this out, is not very functional, right? So one quick tip that I love sharing all the time is that inside of Management Studio, I can go up to Tools, Options, and Query Shortcuts, and then with the Control keys, underneath keyboard query shortcuts, I can map the control number keys to a whole bunch of different stored procedures or other pieces. So for example, I have an SP who is active here, of course. I have SP help text, SP help, the SQL skills version of SP help index. So what I can do is that when I, for example, I'm just looking at a piece of code, highlight inventory flat, I can click on, or just use Control 5, and bang, I've just executed the SP help index, the SQL skills version of it against this particular table. So imagine if I'm looking at a query inside a stored procedure and I just want to do a quick reference. Hey, what's inside this table? Because I certainly don't memorize all of the columns and all of the tables I have to support. Oh, what was that? Or did it use underscores? Did it not use underscores? Because no one has mixes of that, right, in their environment. Of course, we all do because different people have designed stuff. So, this is a great way to, again, use that as a quick reference rather than having to crack open Object Explorer. So that's just a quick tip. Okay, so the next base tool that we're going to be using is a DMV called sys-dmdb index usage stats, okay? So when I execute this, and this is just a raw execution of it, we have a whole bunch of different information in here, including things like user seeks, user scans, and lookup operations and updates. When was an index last seeked or scanned against? These are some very, very valuable pieces of information here. A lot of the other pieces of information in this DMV, like the system seeks and scans, I don't care about that. I don't find this useful because we want to know about users who are accessing our indexes. Typically, we don't care when the system does. Now, inside SQL Server, when it comes to the missing indexes, we have a couple of different DMVs here. DMDB missing index groups, group stats, and details. And then new in SQL Server 2019, there's also missing index group stats query. I'll return to that in a moment. So a quick overview of the three DMVs, the legacy DMVs, is that the first one, index groups, is simply the group handle or the group ID is simply just the primary key essentially for a missing index recommendation. So you see that it's referenced elsewhere, okay? So the index handle is the definition of the missing index recommendation. So that is materialized inside missing index details. So you see how SQL Server is suggesting some equality or inequality columns and so on and so forth here in the second DMV. And then in the third DMV, we have DMDB missing index group stats, okay? So this one has, for the given missing index, unique compilations that would have been helped by its seeks and scans and so on and so forth. There's one key bit of information that's missing from these three DMVs, though. There is no reference back to the original execution plan that generated the missing index recommendation. And remember that it's not the query that generates a missing index recommendation. It is the execution plan, because there are cases where you could have two, quote, different queries that generate the same execution plan, and therefore could generate the same missing index recommendation. Or you could have the same query with different parameters that generate different execution plans as well. We have the joys of parameter sniffing, for example. So that was one shortcoming in the legacy DMVs. However, inside SQL Server 2019, there is a brand new DMV called Missing Index Group Stats Query that allows you to match back to a query hash, and therefore you can actually dig in and find out which queries also generated it. I'm going to share a little confession with you right now. We are currently running this presentation on SQL Server 2017, hence why this is underlined. Management Studio is kind of giving it away that I'm not on a 2019 or 2022 instance as of right now. I have reasons for that. We're not going to get into that, but I just didn't have time to update all my DMVs. Anyway, one thing I want to touch upon here as well is what else do the missing index DMVs miss? There's a number of different fully documented shortcomings about the missing index DMVs. The recommendations are limited in their scope, but the second one is one of the reasons why I don't care for them is that the column order, of the missing index recommendations is in an arbitrary order. So, and we learned earlier that the key columns, the ordering of your key columns is very important when it comes to navigating your non-clustered indexes. So if a missing index recommendations key order column is rubbish, if it's in a pseudo-random order, how useful is that at face value? There's also limited capacity. What do I mean by that? The missing index DMVs, for some reason or other, can only hold 500 recommendations. And then once that tops out, you won't generate any more missing index recommendations. It's a weird one. I have no idea why that one is in place. And then Microsoft has documented very clearly that inequality predicates, so like greater than or less than, the accuracy of a missing index recommendation will vary. And unfortunately, they don't give you an indication. They just warn you that, yeah, it's not going to be as accurate or potentially as helpful, and they have no idea. So understand that these are key tidbits. So that's just a brief introduction to the base tools. Now let's actually get into the exercises of dealing with duplicate indexes and then redundant indexes. Okay. So to review once again, we have a whole bunch of different non-clustered indexes on the inventory flat table here. So what I'm going to do to make parsing of this a little bit easier is I'm just going to dump the output of that stored procedure, the help index, into this particular temp table. Okay. And I find this is very useful. I will do this one, or I have a variation of this that will actually go through all the tables in a given database when I'm doing this at a larger scale in a given database environment, because this is an exercise I recommend that you do on a periodic basis. Okay. But right now, let's just look at a subset of the output, and we're going to sort first just by the index keys to help us as a way to group all of these different things together. And it's very easy to see that we happen to have a couple of non-clustered indexes, for example, where the leading key happens to be identical, model name, but the included columns are slightly different. If we were just using the base SB help index, not the SQL skills version, we would not have included columns at all. So it would actually look like we have three non-clustered indexes that are completely identical. But now we know that they are not truly identical because of the included columns here. We also see we have some other different variations here with the sold ones and whatnot as well. So these are all cases where we have very similar non-clustered indexes that could benefit from consolidation, because let me actually zoom back in on this. if I happen to have a query that's going after, that where blah, blah, blah model name of a vehicle is equal to Camry, the Toyota Camry, right? We can seek on that, right? But if I also happen to have, where, select, invoice price, select MSRP, you know what? This non-clustered index will support all queries that also would be supported and potentially use one of these other non-clustered indexes. That's the idea of this consolidation. Looking for non-clustered indexes where the structure is effectively the same, but maybe the included columns just differ. Because if that's the case, I'd rather mash all the included columns together. And instead of having to maintain 3 non-clustered indexes, it would be better to maintain 1 non-clustered index. And of course, have the storage behind the scenes and so on and so forth, right? So this is the idea of the consolidation, where we're looking for very similar non-clustered indexes that could potentially be compacted and consolidated in this particular fashion. And we're really looking after the index keys first and foremost. So that's one simple example for consolidation. But let's also consider the B tree structure and a couple of pieces of information that I talked a little bit about earlier. I want to focus in and zero in on the non-clustered indexes that happen to have the sold column here. So as you can see from the index keys, we have a whole bunch with the sold column where there's different variations where sold price and the VIN number shows up. And then we have the included columns as one of them has the inventory flat ID as an included column. Another one has inventory flat ID as an index key column. However, Kimberly also includes these other 2 data points inside her version of SP Help Index. Columns in tree and columns in leaf. Remember the visualizations that we showed earlier? And remember how I shared with you early on that the clustering key will also be materialized implicitly in all of the values that will show up in the intermediate levels and then also in the tree, in the leaf level itself. So inventory flat ID, which is our clustering key, will show up everywhere. What that means is that these 2 non-clustered indexes here, even though they are defined differently because one happens to have inventory flat ID in the index keys and one happens to have inventory flat ID in the included columns, structurally, these are exact duplicates of one another. And that, of course, is a waste. There's no point to this whatsoever, right? So something to be very mindful of. And that's why having these 2 values here can be very, very useful. Because unless you know SQL Server internals, if maybe you've never been exposed to this information before, you may think or not even think about that clustering key and whether to include it or not, right? Or, the fact that it comes along for the ride. So I always love sharing this little bit as well. Just again, show you how that is something that's very important. And then in the case of, these 2 non-clustered indexes, for example, you know what? I don't really even need this one up here. The one with sold price here as an extra included column would be another good example for that consolidation. Or I may not care, depending on my workload, as far as inventory flat ID, being that second value versus the third value here, I may just want to consolidate all 4 of these non-clustered indexes down to 1. And this is where you also have to look at your index usage patterns, which we will get to shortly.
Andy, we do have a question.
Yes.
Stephen wants to know, if I have a query that does not include a column from the index, is the index still used?
So the answer to that is maybe, and it depends. The query optimizer will make a choice, and there's no kind of hard line in the sand, if you will. It's kind of a gray area whether SQL Server will choose to do a key lookup operation or tip and actually just do a full index scan. So what I want you to do is go look up a concept called the index tipping point. That is where, so Kimberly Tripp on SQL Skills has written a bit about the tipping point. Greg Gonzalez from SentryOne has also written about the tipping point as well. Long story short, though, is that the threshold is actually quite low. This is one of the reasons why single column indexes generally suck. Because oftentimes we need more than one single column, right? So oftentimes we'll think that, oh, I have this single column index, we'll seek on that and we'll just do a key lookup operation. Well, oftentimes, unless the number of records that come back from that is really a small subset of the entire table, SQL Server will just tip over and say, forget it, I'm just going to scan the entire thing. So go research the tipping point. Okay, I hope that answers the question. Any other questions?
No, we do not have any other questions, and I found Greg's blog on SQLperformance.com about the tipping point, and I put that in the chat for everyone.
Outstanding. Thank you. I appreciate the help.
Yeah, I have to drop at 1 o'clock, so
Understood.
hopefully some pick up for me.
All right. Okay, so now we're going to get into index utilization. So I have my own version of DMDB index usage stats query here. So this joins with a whole bunch of other tables. But the idea is that this will give us a whole bunch of information in addition to like the index names, the table's name, and that sort of thing. So now we can actually see index utilization. I've already run some workload here in my demo environment, so we can pretend that this is like our production workload. So I can now use this information to get a better sense of whether index information has been used or not. Understand that this particular DMV, the usage stats, is always ever increasing until you reboot your SQL Server. So it may be a good idea for you to save this information off on a periodic basis. However, something that will persist is query store information, and Kendra Little here has some fantastic writing about whether you can find somewhat similar information in the query store. And it's not as efficient to find all items. You're better off saying, you know what, based upon this, I want to dig into one of these different non-clustered indexes and look inside the query store to see if I have additional information about it in the query store, to see what indexes and what queries utilize this particular index here. So now I can dig into that, dig into some of their execution counts and what the actual overhead was. Okay, so this can be very useful, and hopefully you have query store turned on these days. For the demo purposes, I'm going to use a slimmed down version of my diagnostic query. And again, remember the diagnostic query is available up on my GitHub. So let's take a quick look at this and see, are there any non-clustered indexes in here that we could remove? If we assume that the index usage stats are accurate and representative of a workload cycle, then we could potentially use this to find candidates to get rid of, right? When I say workload cycle, remember that many of us happen to have indexes that support month-end or weekend reporting and things of that nature, as opposed to day-to-day type stuff. But if we assume that, you know, hey, then I got a whole bunch of non-clustered indexes that haven't been touched by anything in quite a while. No seeks, no scans, or nothing. These are great candidates to just get rid of because they're no longer being used by my workload, right? So that's the idea of using all of this information to kind of dig into that, okay? So let's talk a little bit about savings here. So I'm just going to show a simple example here where this is now going to show me for the inventory flat table, how many data pages are there in grand total? About 54,000. And in grand total, this consumes about 400 some odd megs of space. So now that we've copied that, the other place is, you know, we talked about, you know, the overhead of, you know, DML operations behind the scenes, right? So to measure that, we're going to look at the volume of transaction log that is written to when I run this particular store procedure that does some DML workload. So I'm going to execute this as my baseline. See how long it takes, and then generate, you know, how long it takes and how much transaction log was generated. So this is the volume of transaction log in bytes, and my total execution time was about 5 seconds or so, 54.92. Okay, so what I'm going to do is I happen to have a cleanup script here already. Let's pretend we've gone through the exercise. We've identified the things that are redundant and that we're going to consolidate and all that other kind of good stuff. And then some other things that we're going to nuke. Okay, so we're going to just go through this cleanup. Now let's see what kind of savings we actually have. So first of all, just from a space used perspective, instead of 54,000 data pages is now down to 29,000 data pages, or instead of 428 megs of data, it's now 233. That's a huge space savings from a capacity perspective. you know, it's not much in the term of megs, but this is a demo database. Think in terms of percentages here, right? Because we got rid of a whole bunch of stuff hanging out behind the scenes. Let's take a look at this DML workload store procedure, and actually take a look at that. Transaction log bytes used here, and then down here as well. So my execution time has decreased, and the volume of transaction log I had to write is also reduced as well. So we have some savings here, 24%, 39% savings, just because we cleaned up some indexes behind the scenes. Wouldn't you love to tell your manager that just by doing some index cleanup that you were able to improve some of your workload? I would love to say that. So it's a great way to kind of potentially, try and identify things that, just need some kind of cleanup. So I'm going to go back and run some workload because I've now blown away my indexes and reset a bunch of stuff. So I just have some workload scripts here to generate some index usage information here. And then with that, we're going to start checking our index reusage here. And typically, we'll want to do this after the workload has been running for a little bit. But the point more being is, hey, are our new indexes being used? In this case, this one is being used. Typically, when I let the workload run a little bit longer, then we'll start seeing usage out of some of these other non-clustered indexes as well. So, yep, we have a couple of other queries that have run, and hit this particular non-clustered index. This one has not been hit yet, but will be hit because I know my workload queries. But in either case, as my workload keeps running, all of these new non-clustered indexes will now be leveraged. Yay. These are things that will cover more of my workload. That's the point here. So all of that is pretty good. So now what I want to do is pivot and spend the last few minutes briefly talking about missing index DMV, missing index recommendations and stuff. So we have some workload that's running, and this is a much larger scale missing index DMV query. One of the things that it happens to have here is something called an improvement measure. This improvement measure is just a mathematical calculation based upon the projected user cost, average user impact, and number of seeks and scans. The idea here is that it's just a generalized number to give you a better sense of, is this something that could potentially help me out here or not? So it's something that I use as a ranking value to kind of assess this, right? So what I'm going to do is I'm going to, I'll execute this one more time. We have a little bit more data in here. And now I'm going to copy this out to Excel. This is how I kind of like to evaluate the missing index recommendations. This is kind of the workload analysis bit. So, typically we would have higher numbers, of course, because our workload will be doing a whole heck of a lot more work. But we're going to run with what we happen to have right now. So inside this index, this Excel document, what I like to do is apply some sorting here. So let's see, go to the Sort tab. So I'll sort by database name, table name, equality columns, inequality columns, and then the improvement measure from largest to smallest. So now I'm going to have a better sense of where things kind of line up with one another, and then kind of get a ranking based upon. Now, when I'm looking at the improvement measure, these are just in the hundreds or low thousands. When I typically look at a true production workload, I see values in the hundreds of thousands, if not the millions, or even larger numbers than that. And usually, instead of being somewhat similar to one another, it'll be pretty obvious which of the missing index recommendations have much higher values and, therefore warrant your attention here. But we can very easily see off the bat, even with the missing index recommendations, that there's a lot of potential overlap here. Okay, this is great. Well, now I can even just apply some of what we've learned in the exercise prior about consolidating some of these and then potentially taking a closer look at that. If you're on 2019 or later, I can even now dive into the queries to get a better sense of whether the key orders for these equality columns actually make sense or not, right? For example, with some of these where there's multiple equality columns, are we, which one are we going after first? Which one are we going after more often? This is where I'm now going to want to start referencing Query Store to kind of get at some of that information, right? So I'm going to make use of this Excel document again to do that kind of analysis, to kind of split things back and forth. I might also resort by the total number of seeks and scans that would benefit from this, and so on and so forth, right? So I'm going to make use of all of these, but I like using Excel to basically zero in on maybe one table in my database, or, you know, and that sort of thing, because maybe I happen to have just one table that has tons of different missing index recommendations. Or, you know, if I have a database that has hundreds of tables, okay, I'm going to pick the top 5 tables and then zero in on that. Right? So Excel makes it a lot easier to slice and dice this information. And of course, as I'm going along, I'm going to want to refer back to the existing missing index, or the existing non-clustered indexes as well. Are there existing non-clustered indexes that I can combine with a missing index recommendation to potentially consolidate those as well, right? So that's something to be very mindful of. So you want to kind of do that as well. I don't have time for this right now because this is typically a 75-minute session, but one of the things I talk about here is, do I want to potentially start applying filtered indexes? Because one of the missing index recommendations that came up was sold. The sold value is a bit column in my table, so it's only going to have 2 values, 0 or 1. So should I create a filtered index where sold is equal to 1 or sold is equal to 0? So I kind of go through this back and forth here, and sometimes that's what you're going to have to do, is create both indexes and run a sampling of your workload to see whether a given index given index variation will truly help out your workload or not. Right? So this is the art and the science behind, you know, evaluating some of these, and or, you know, also cross-referencing back to see if there's any consolidating or missing indexes that you can kind of work together with. Okay, back to the slides. Let's take this on home. So I hope over the last 50, 55 minutes or so that, you know, I've been able to give you a better sense that, you know, duplicate and redundant indexes are worth cleaning up over time. I won't do this every week. That takes way too much time, but I'll try and typically do this once a quarter or once with every single major release of a given application. Missing indexes can be useful, but never take them for face value. But really, the most important thing is to know your workload. Have some kind of monitoring in place. Or if you're managing many, many different databases and you can't know your workload, use Query Store or use some other kind of monitoring tool to better understand and quickly analyze the patterns of your workload. Now, if you're more curious about missing indexes, yes, I did gloss over that a little bit here because I now have an entire presentation about the do's and don'ts of missing indexes, something that I developed and debuted last year. So you can go out to YouTube. There's a couple of different recordings that are floating out there. So just search for my name and missing indexes, and you'll find a couple of different recordings of the do's and don'ts of missing indexes, where I dive even more into the missing index recommendations and when they can be useful, when they may not be useful. So with that, let me kind of wrap things up. We have 4 minutes left for any final questions. Kevin, if you're there, I cannot read the chat right now. So, you know, if you or Andy or someone else could just read the chat questions to me, I would greatly appreciate it.
Sure. So we have a question from Lars. Should we disable non-clustered indexes during rebuilds?
I answered that previously while you were away, but the long story answer is no, because when you rebuild when you take a non-clustered index and quote re-enable it, that's a rebuild operation. Next question.
All right. Do you find yourself creating filtered statistics versus filtered indexes?
That's a great question. I actually happen to have a completely different presentation all about statistics. So it was like a practical guide to statistics or something like that. Generally speaking, though, I don't find filtered statistics to be very useful. It's more of a narrow scenario for them. But if you really want to dive into my session on statistics, you can go Google and YouTube my name and statistics, and that recording of that one should also be floating around.
Perfect. And that seems to actually be all the wonderful questions we have.
All right, so thank you everyone for participating today. If you could do me a quick favor in the chat, and of course, Kevin, you'll have to report this back to me. Just give me a quick like +1 or a -1 or a 0 if this session met your expectations and you found it helpful. It's just going to be kind of like my quick bit of feedback here. And you know, if for whatever reason this was not a helpful situation or a session for you, and you have some feedback for me as to how it can improve, please drop me an email and share that feedback with me. You're not going to hurt my feelings. I want to be able to improve, you know, as I go along. But otherwise, I appreciate your time today. I hope this was useful to everyone, and thank you all for joining me.
All right. So with that, we do thank you all. Yes, these scripts, I know, Andy, the scripts were on GitHub.
Yes.
No worries
yes.
there. So with that, we do thank you all for coming, and be sure to join us next time when we have Hugo Cornelis speaking on execution plans. Where do I start? So with that, thank you everyone for coming. Hopefully y'all enjoyed it, and we'll see us next time. Thanks, y'all.
Wonderful. Thank you.